This is a brief overview of problems that I experienced trying to mill a component for my aircraft. The component is a counterbalance for an elevator. As you can see, this was modeled in Solid Edge, which is a 3D modeling program. And I take this component that I modeled in Solid Edge, a very simple component, and want to mill it out of aluminium on my CNC routing machine. At this juncture, I'm just going to quickly show you the tool chain that I use so that we can identify where I experience problems. The tool chain starts off with creating the part in Solid Edge, which is a 3D modeling package. I then save the file as an STL file, which I read into DesProto. DesProto creates tool paths for the CNC machine for both the roughing and smoothing process. It outputs a CNC file into winpcNC, and this is where I got stuck for many hours, which I'll discuss in short time. The winpcNC sends the CNC file out through a USB to parallel converter into the machine controller. A short segue here just shows the type of machine I've got. It's a Heiss S720 with a Crest 1050N mill. The 720 allows the gantry or the head, the cutting head over here, to move 720 millimeters in the X direction, 400 in the Y direction, and 110 millimeters up and down in the Z direction. This is the piece of aluminium, the block that I wanted to machine. It's worth noting that on any of these routing machines, you've got an X0, Y0, Z0 position, which is the home position of the machine, and you've got to manually move the tip of your cutting tool to this corner here to set your X0, Y0, Z0 for your workpiece. This machine has got two X driver motors to move the gantry up and down, a one motor, stepper motor to drive it in this direction in your Y direction, and one Z motor. You can see here that I was unable to control the speed accurately of the end mill. This is the rotation speed. So I purchased a Super PID version 2 speed controller when I had to modify the Crest end mill to get the rotation speed coming back, and then this closed loop allowed me just to dial in with a potentiometer and say, for example, I needed 6,500 RPM. You can dial it there, and the speed controller does pulse width modulation to the Crest end mill. So this is really a worthwhile addition to one of these little hobby routers. When I ran PCNC, this is the NC program that is received from the upstream tool chain. You can see here at a feed rate of 2,000 millimeters per minute, which is the maximum rate for this particular machine. Here's that bracket that I wanted to machine. You can see this is the path that's traversed by the end mill, and these are the XYZ coordinates in the NC routing program. When I tried to mill it, it started crawling through the material at a very low rate, and I couldn't understand why this feed rate wasn't being implemented. I then checked in my setup, and in the parameter here, I had set the rapid and the manual speeds to 30 millimeters per second, which comes out very close to 2,000 millimeters per minute, and yet it was still crawling through the part. After many frustrating hours, I then found out that you have to go in the parameter setting not to speeds but to tools. And in the tool dialog, I was using a 6 millimeter end mill, which was tool number 1, and you explicitly have to set the feed rate for each tool. So this speed is nothing to do with that speed. This is the global maximum speed for your machine, and this is the speed you want. And it's not actually the speed, it's a bit misleading. This is the feed rate for that tool. So once I'd gone there, I saw for tool number 1, the default is 5 millimeters per second. I had to set it to 30 millimeters per second here, which is the advanced. This correctly should read feed rate, then I would know what it was. And this is the tool speeds. Here you've got the plunge, this is the feed rate, and this is the withdrawal. So the speed that the tool goes through or up and down in the material, not the rotation speed. Once I'd figured this out and set it correctly, things proceeded very smoothly and I managed to finish the parts for my aeroplane.